Hello, I'm Laura Gortana, and this is my Advanced Functions CCT. Today we'll be looking into the Nelson's Advanced Functions textbook to answer an AROC and IROC question. AROC stands for the average rate of change. The average rate of change calculates change of a polynomial from one point to another. IROC stands for instantaneous rate of change. The instantaneous rate of change calculates the change from a specific point on a polynomial. The question we will be looking at is on page 87, number 7. Number 7 states the population of a town in thousands is described by the function pt equals negative 1.5 t squared plus 36t plus 6, where t is the number of years after 2000. We'll be starting off with 7a. 7a asks, what is the average rate of change in the population between the years 2000 and 2004? To help you further understand AROC, I will help explain the equation. The equation of AROC is very similar to slope. The equation for slope is m equals y2 minus y1 over x2 minus x1. For AROC, we have fx2 minus fx1 over x2 minus x1. Or in our case, AROC is equal to pt2 minus pt1 over t2 minus t1. As you can see, it's very similar to slope. To start off, you need to find your t value to plug into your AROC equation. Since t is represented as the number of years after 2000, you need to subtract 2000 from the year to find your value of t. 2000 minus 2000 is 0, and 2024 minus 2000 is 24. So, to solve for 7a, you are solving for AROC between 0 and 24. First, you plug in your t values into your original equation. The equation pt equals negative 1.5 t squared plus 36t plus 6. Let's start off with solving for p24. You plug in 24 into your t value. Now that we have solved for p24 and got an answer of 6, we can now solve for p0. Now instead of plugging 24 into your t value, you plug in 0. Now that we have solved for p0 and got an answer of 6, we can put both of those values into our AROC equation. The value that we have solved for AROC between 0 and 24 is 0. So, therefore, the average rate of change between the years 2000 and 2024 is 0 people per year. Now let's move on to 7b. 7b asks, does your answer to part A make sense? Does it mean that there was no change in the population from 2000 to 2024? The answer for 7b may vary because 7b is a communication question and can be worded multiple ways. Personally, yes, 7a makes sense. The average rate of change is 0, meaning the population doesn't change. This simply means there were the same amount of births as deaths throughout the years, showing the population has not changed. Now let's move on to 7c. 7c asks, explain your answer to part B by finding the average rate of change in the population from 2000 to 2012 and from 2012 to 2024. The question 7c is very similar to 7a. You are finding the AROC of 2000 to 2012 from 2012 to 2024. It's pretty much the same steps as 7a, except with different variables. Let's start by finding our t values, again just like from 7a, by subtracting 2000 to the year. 2000 minus 2000 equals 0, 2012 minus 2000 equals 12, and 2024 minus 2000 equals 24. Now that we have found our t values, we can plug them into our equations. Let's start with finding the AROC from 2000 to 2000. First, we shall plug in our t values of 0 and 12 into our AROC equation. Let's solve for p12 first by subbing 12 into our t variable in our original equation, pt equals negative 1.5 t squared plus 36t plus 6. Now let's solve the equation for p12. Now that we have solved for p12 and got an answer of 226, let's move on to solve for p0. Now to solve for p0, we need to plug in 0 as our t variable into our original equation. Now that we have plugged in 0 for our t value, let's solve for p0. Now that we have solved for p0 and got an answer of 6, we can take our answer from p12 and p0 and plug it back into our AROC equation. Now let's solve for AROC from 0 to 12. Now that we have solved AROC from 0 to 12, we came to a solution of 18. But we can't forget that the population is in thousands, so it's 18,000 rather than 18. Now let's move on to solve AROC from 2012 to 2024. Let's start by solving for P24. Now let's plug in our new t-value of 24 into our original equation to solve for P24. Now that we have plugged in our value of 24 into our original equation, let's solve for P24. Now that we have solved for P24 and got a solution of 6, let's move on to solve for P12. Now we can either take the answer from the last AROC equation we just solved for P12 to save time. We can do this because we would be doing the exact same work we did previously by plugging our t-value of 12 into our original equation. We would get the same answer because we are plugging 12 into the same equation. But if you would like more practice, you can plug our t-value of 12 into our original equation to solve for P12. Now that we have solved for P12 and got a solution of 222, we can take our P12 value and P24 value and plug it back into our AROC equation to solve for AROC of 12 to 24. Now that we have plugged in our values, we can solve for AROC 2012 to 2024. Now that we have plugged in our values, we should have gotten a solution of negative 18. Again, don't forget that the population is in thousands, so it is negative 18,000 rather than negative 18. So now we can answer the original question of does our answer from 7b make sense? So as you can see, both increase and decrease by 18,000 people per year, hence why the AROC from 2000 to 2024 was 0. The AROC increases but then decreases by the same amount throughout the years. Now we can move on to the final question, 7d. 7d asks, for what value of t is the instantaneous rate of change in the population 0? For this question, you can find out the year by using the knowledge gained from the previous answers. Since the population doesn't change over the 24 years, you know that it is because there were the same amount of deaths as births within those 24 years. From 7c, we learned that between 0 to 12 and 12 to 24, the average rate of change is 18,000 people per year. The year that overlaps is where the change occurs, which is 12, or 2012. That shows that at this point, either deaths are greater than births or vice versa. To test that 12 is the correct time, you plug it into your IROC formula. The IROC formula is very similar to AROC. To calculate IROC, it is very similar to AROC. The formula for AROC is the same as IROC. The only difference is that AROC uses 2 different points from your polynomial and IROC only uses 1. So to get the closest answer to the exact value, you plus and subtract 0.001 to your IROC value that you need to solve for, and in our case, that value is 12. So to start off, let's add 0.001 to 12 to equal 12.001. And now we subtract 0.001 from 12 to get 11.99 as our two values to sub into our AROC equation to solve for IROC. Let's start by plugging in 12.001 into our original equation, pt equals negative 1.5 t squared plus 36t plus 6. Now that we are plugging in 12.001 as our t-value into our original equation, we are now solving for P12.001. Now that we have solved for P12.001 and got an answer of 222, we can move on to solve for P11.999. Now let's solve for P11.999 by plugging in 11.999 into our original equation as our t-value. Now that we have plugged in our t-value, let's solve for P11.999. Now that we have solved for P11.999 and got a solution of 222, we can plug both answers of P11.999 and P12.001 back into our IROC equation. Now that we have plugged both of our values back into our IROC equation, we can solve for IROC of t equals 12. Now that we have solved for IROC t equals 12 and got a solution of 0, it is evident that the population at t equals 12 is 0, so the year 2012 is when the population is equal to 0. So we are now completed the question. Thank you for listening. Hopefully I was able to help you further understand rate of change. And thanks for listening in on my math CCT. Bye!